Alrighty, hello. So, day 6. Today we're going to be looking at Lussac's law. Looking at today's daily tasks here. Remember, your first thing to do is to make sure you check that homework from earlier this week on Charles' law. Those answers are posted right above here on the answer document. And then after watching this video, you'll have some more practice problems. So, let's get started with our notes for the day. Just like usual, you will need the note sheet that we've been working on for the gas laws unit. You'll also need a calculator again. Today's learning target is that students will interrelate pressure and temperature. So again, looking at two things you already know about, looking at temperature, looking at pressure, seeing how these things relate, learning a new equation to solve involving temperature and pressure. So, Lussac's law states that the pressure of a gas varies directly with the temperature in kelvins. So, pressure, the amount of force exerted on something. Temperature, how hot or cold something is. And we're measuring that again in kelvins. So when we looked at Charles' law, you got a lot of familiarity with kelvins and how that works using that magic number 273.15. Don't forget that you will need to continue to convert Celsius and kelvins moving forward, especially in the coming weeks as we put all these laws together. Notice in this definition it says the pressure of a gas varies directly. So just like when we talked about Charles' law, we're using the word directly again. Recall that directly means the same. As one thing goes up, the other will go up. As one thing goes down, the other will go down. So if pressure increases, temperature is also going to increase. So keep that in mind again when we go into the practice problem in a moment here. Just like before, I have a little graph for you of Lussac's law. So as temperature is increasing, pressure is also increasing. So as you can see, as we go up in temperature, we go up in pressure. And the same would be true, but in reverse. Oh, I can change the color. I didn't know I could do that. As we go down in temperature, the pressure also decreases. And the formula that you're going to need to know for this is as follows. Same setup as usual, just with our variables we're using. P1 over T1 equals P2 over T2. So again, initial pressure divided by initial temperature is equal to the secondary pressure over secondary temperature. And make sure those units are the same on both sides. So let's look at our practice problem for today. The gas in a container is at a pressure of 3 atm, or atmospheric pressures, at 25 degrees Celsius. Directions on the container warn the user not to keep it in a place where the temperature exceeds 52 degrees Celsius. What would be the gas pressure in a container at 52 degrees Celsius? Let's go over to our whiteboard. Alrighty, so I put the whiteboard a different direction today, so we're going to see if it works a little better. So, just to remind you, the formula we're going to be using is P1 over T1 equals P2 over T2. I want to pause a moment and just make a quick suggestion. You'll notice that we're going to be learning several different formulas, just like we did with stoichiometry. I think it would be very helpful to you to keep a separate document, a separate piece of paper, and just write out each of these formulas. So when we come to quiz next week, you can have those formulas right in front of you and you're not searching through your notes to find them. So just write Lussac's law, write down this formula. Write Charles' law, write down the formula, and Boyle's law, and so on and so forth. So as we solve this problem, just like with Boyle and Charles' law, our first step is going to be to write our variables. So our P1, it tells us that our P1 in this situation is 3 atm, 3 atmospheric pressures. And it tells us that our temperature initial is 25 degrees Celsius. This problem is a lot wordier than the other problems. It doesn't tell you what your final pressure is. It instead tells you that a final temperature is 52 degrees Celsius. And it doesn't straight up say the final temperature. It just gives you a temperature that you want to end with. So we're looking at 52 degrees Celsius as our final temperature, and we don't know the pressure. We're looking for that second pressure. So as we plug these in, we will get 3 over 25 equals x over 52. Sorry, that's really crooked. We're going to solve this just like we did earlier this week with Charles' law. 3 divided by 25 will give us 0.12 equals x over 52. We need to get that 52 out of there, so we're going to multiply by 52 on both sides. And that will give us 6.24 ATM equals x. Remember, I'm getting this ATM unit because we started with ATM. We're going to end with ATM. So make sure you're paying attention to that. Remember, we use that word directly, again, when talking about Lusac's law. Notice that temperature is increasing, which means that our pressure should increase, and we do. We increase from 3 to 6. So that is how you solve this problem. Alrighty, so since we finished that problem up, after that you will have some practice problems. So just like we've been doing the other couple days, your homework is linked right below today's video under day 6 homework, and that is going to be due on Sunday, so make sure you have it in by then. The homework is going to look exactly the same as Boyle and Charles's law. You're going to be using that website again, following along with some practice problems, answering a couple questions, and then doing just a couple practices on your own. I do want to give you a little warning. Make sure you pay special attention to this final problem here. Notice I want my final answer in Kelvin instead of Celsius, so you will have to do an extra conversion at the end. Again, make sure you reach out if you have any questions at all, as this is getting a little more complex. We're adding in some extra formulas, and remember, you will have a short quiz on this come next week. So after you finish that homework, let's just go through our daily task list again. Make sure you do the practice problems like I just said. Make sure you're looking over the information. You have no questions because you will have a quiz come next week. Just to give you a little look ahead, that quiz will be on the will be due by the end of the week, so it will be due next week Friday, so you will have some time to do it. And again, make sure you're continuing to work on your final science fair project. That work is due on May 8th, so that is due on this week Friday. So you need to have your topic selected by Friday this week, May 8th. So remember, if you don't know where that is, scroll up to the top, go to your science fair topic selection, and make sure you turn that in here using that Google form. If you have any questions, let me know. Make sure you use their extra time today to work on your project. Have a good day.